Today, we're diving into a really fascinating paper called SkillsBench, and it tackles this huge question. When we try to give AI agents these special skills, these playbooks, does it actually work? Does it make them any better at their jobs? Let's find out. So let's set the stage with a problem that I'm sure feels very familiar if you've ever worked with AI agents. You have these incredibly smart models, right? They've absorbed basically the entire internet. But then you ask them to do a seemingly simple, multi-step job, and they just fall flat on their face. What is going on there? What's the disconnect? Well, the paper uses this perfect analogy to explain it. Imagine a genius who's just graduated. They've read every textbook, they know all the theories, but they have zero on-the-job experience. That's kind of like our AI. It knows what a financial report is in theory, but it has no idea about the specific step-by-step process your company uses to actually create one. Okay, so if the problem is a lack of on-the-job training, how do we fix it? Well, the solution proposed here is this concept they call an agent skill. Now, a skill here isn't just more raw information. This is the crucial part. It's a digital playbook. It's this structured, curated package of how-to knowledge. Think step-by-step instructions, maybe some code snippets, best practices. It's all about the how, not just the what. To really make it click, think about it like a computer's tech stack. The base AI model, like a GPT-4, that's your CPU. It's just raw processing power. The agent harness around it is the operating system, coordinating everything. And the agent skills, well, those are the apps you install to do specific jobs. You wouldn't expect your OS to edit photos, you'd install Photoshop for that. It's the same idea. An idea is just an idea, until you test it, right? So these researchers didn't mess around. They built SkillsBench, which is basically the ultimate AI agent obstacle course, designed to see if this whole skills thing actually holds up under pressure. And this was no small test. We're talking 86 really complex real-world tasks. And they're spread across 11 totally different fields, from healthcare and finance all the way to robotics. But here's the best part. Every single task has an automated verifier. There's no gray area, no, it kind of did it. It's a simple binary pass or fail. Clean data. So to run a proper experiment, they set up 3 different conditions. First, you've got your control group. The AI agent is on its own with no skills at all. Second, the main event. The agent gets access to these high-quality, expert-written skills. And third, and this is a really cool twist, they asked the AI to try and write its own skills before it started. The big question. Can the AI teach itself how to do the job? All right, so they ran over 7,000 trials. The results came in, and what the hard data showed, well, it's pretty surprising and honestly incredibly revealing about what works. Let's just start with the single biggest headline number. On average, just giving an agent a curated, human-written skill boosted its success rate by a whopping 16.2 percentage points. In this field, that is a massive leap in performance. Okay, let's put that number in context. Look at this chart. Without skills, the agents were passing about 24% of the time. Not bad. With the expert skills, that shoots up to over 40%. But then look at that third bar, the self-generated skills. The performance actually went down. The AIs were literally worse off when they tried to write their own instructions. And this quote from the paper just hits the nail on the head. It turns out there's a huge gap between being able to follow a good set of instructions and being able to write those instructions from scratch. The models are fantastic students, but they are not the domain experts, at least not yet. And just to really hammer this point home, the change in performance when the AI wrote its own skills wasn't zero, it was negative. On average, trying to be its own expert made the AI slightly worse than just relying on its general knowledge. But here's where it gets even more interesting. This benefit wasn't spread out evenly. In a field like software engineering, where the models already have tons of training data from the internet, the boost was pretty small. But in these super specialized domains like healthcare, with its unique procedures and jargon, the performance gain was a mind-blowing 51.9%. That tells you exactly where these skills are most valuable. The researchers also wanted to know, okay, how many skills should we give an agent? Well, it turns out that giving it just a single, highly relevant skill gave it a solid 17.8% boost. Adding a second or a third relevant skill nudged that up just a tiny bit more, to about 18.6%. And it seems like that's the sweet spot. Because then, things get weird. You'd think more skills is always better, right? Nope. When they gave the agent 4 or more skills, the benefit absolutely plummeted, all the way down to under 6%. It seems that too much information, even good information, just creates cognitive overload and confuses the agent. So the lesson is clear. Less is more. And this visualization just sums it all up beautifully, doesn't it? On the left, without skills, you see a whole lot of red, a lot of failures. On the right, you give it skills, and the whole picture shifts dramatically to blue, to success. It really couldn't be clearer. Okay, now this might be the most important practical finding in the entire paper, especially for people actually building stuff. Check this out. The huge, top-of-the-line, expensive Claude Opus model, on its own, passes 22% of the tasks. But the much smaller, faster, cheaper Haiku model, when you give it good skills, passes almost 28% of the time. A smaller model with the right playbook can actually beat the giant. This is huge.
So what's the big picture here? What does all this mean for the future? I think it really gives us a whole new playbook for how to build effective AI.
If you remember 3 things from this, make it these. 1. Curation is king. The secret sauce isn't just a bigger model, it's capturing real human expertise and putting it into these skills. 2. Less is more. Don't drown the AI in a giant instruction manual. Give it a few focused, well-written skills. And 3. Skills are a powerful equalizer. They let smaller, cheaper, more efficient models punch way, way above their weight class.
And that leaves us with this final thought. If the underlying AI model is just becoming the engine, a powerful but increasingly commoditized part of the stack, then is the real race even about building the biggest engine anymore? Or is the new competitive frontier all about who can build the best, most comprehensive library of expert skills to run on top of that engine? This paper makes a pretty strong case that the race has already shifted.